All right, so here is Unit 1, Objective 5, Domain Restriction. So make sure you remember from previous objectives how to graph the four functions: linear, linear absolute value, quadratics, and exponentials. Those are the four functions we're going to be working with this entire unit. Okay, so in this objective, we're going to learn how to restrict a domain. Okay, so let's take a look at the definition here slowly. Domain restriction graphing is the process of graphing only a part of the entire function. So if you know how to graph the entire function, then you can go ahead and just trim it a little bit and learn how to graph just part of the function. Okay, if I know how to graph an entire function, I can trim it and graph only part of it. Okay, so that's the process we're going to be doing. We're going to be graphing just part of the entire function. And how do we do this? Well, we restrict the domain. It says the domain is restricted by looking at only a part of the values of x. Okay, domain, when we are talking about domain, we're talking about values of x. And I want to restrict the domain, so I want to restrict the values of x's. Okay, we only look at part of the values of x's. So, here's what we're going to do. Let's go ahead and do a quick little recap. I'm going to do it in pencil. So, example number 1. For the function f of x, which equals x squared. So let's do a little recap here. We have a squared, so that tells me that this is a parabola. Okay, this is a parabola. It either opens up, a U shape opening up, or a U shape opening down. Okay, it depends of the a value. When I look at this, I remember that's my parent function. That's the simplest parent function of the parabolas. So we take a look at this invisible value in front of the parabola here of the x squared, and that is the value of a. So our a value equals 1. It's a positive 1. So we know our parabola opens up. Okay, so I'm dealing with an open up parabola. And because the parent graph starts at 0, 0, so our starting point is 0, 0. Okay? So if I was just simply to recap what this function is a parabola that has a positive stretch of 1, so it opens up, and it starts at 0, 0. So I'm going to do it in pencil. If I was to graph this parent function, I would start at 0, 0 right here. Okay? I would go up 1 and over 1 to the right, and I would reflect it to the left as well. And I would have this U shape right here. Notice I'm doing in pencil, so don't do it yet. Just watch me do it first. Okay, so there you go. I have my U-shaped parabola. However, this objective, we are restricting the domain. Okay, it's a domain restriction. So here is the restriction. Is the very first bullet point is the restriction. Restriction. Okay. Here's my restriction. It's saying you're going to graph f of x if x is less than 2. Okay? In other words, you're going to graph this function, but only, okay, I'm going to use another word for if. You're going to graph f of x only for x values that are less than 2. So here on my domain, which are the x values, I am supposed to stop at 2. I'm going to mark the 2 right here. Okay? I'm supposed to stop here. I'm not supposed to pass because I want only the x values that are less than 2. Well, I'm going to use green to show you the x values that are less than 2. The x values that are less than 2 is 1, 0, -1, -2, in this direction right here. These are all the x values. I'm just shading my x values that are less than 2. Anything less than 2 here to the left. Okay, that's what my restriction is saying. Graph the function if or only for x that are less than 2. So I'm not allowed to pass. I'm not even allowed to use the number 2 because I don't have an equal. Because we don't have an equal under here. okay, is only a less than 2, I'm not include the 2. Okay, let me say it again. Because I don't have an equal under here, I'm not including the 2 as well. Okay? So let's go ahead and take one step further. Let's go ahead and evaluate. That's the next bullet point. Let's evaluate. Let's evaluate what happens when I plug in a 2 for x in my function. So in the place of the x here, I'm going to replace it with the number 2. So 2 squared. So f of 2 equals 2 squared, which equals a 4. 2 squared is a 4. That creates an order pair for me. When I plug in a 2 for x, I got a 4 for y. So my graph should be touching 2, 4. So here's 2, up 1, 2, 3, 4. Right here is where my point on the graph should be. I should stop right there and erase it. Anything above that, I should erase it. So I'm going to erase it, okay? With the eraser here, it's gone. However, there's one more thing. Because I'm not including the number 2, I should not put a closed dot, because a closed dot says I am including the point 2, 4. I don't want to include the 2. The 2 is not allowed in my domain. So I'm going to have to erase that closed dot. Let me erase it. And to show that I'm getting really close to the 2, I'm going to put 2, 4, 1, 2, 3, 4. I'm going to put an open circle and stop right there, okay? So that's how I show that my graph goes all the way to a 2, 4, but I put an open circle, but on the left I'm okay to go up forever, okay? So that's what my graph's supposed to look like. I restricted my domain. I used all the x values that are less than 2. At 2, 4, I'm not including it, so we keep it open circle, okay? So that's how you graph a part of the function. So find the domain and range in interval notation. Remember interval notation, if you have to go back and remember. Interval notation, we use brackets or parentheses. It depends if we want to include it or not include it. So I'm going to write brackets mean include, and parentheses means not include. If I want to show something's not included, I use parentheses. If I want to show something's included, I use brackets. So let's talk about the domain first. So let me put a D for domain. Okay, domain, I made sure to highlight it for you. Okay, is all the x values that are less than 2. Coming from negative infinity here, from the left, all the way to the 2, but I'm not including the 2. So our domain is going to be parenthesis for negative infinity, comma, 2, and we're not including the 2, so we're going to also put parentheses. Okay? Let's talk about our range. And our range is the y values. So I started as 0, right here, 0, 0. So that's the lowest point. I am including it, so let me start as 0. And I'm going up to positive infinity. Now you may say, Mrs. Myers, it cuts off at 4. Yeah, but on the left, our range keeps going forever and ever and ever and ever. So on the left, we're going forever, so that needs to be counted for. Even though on the right, we stopped at 4, but on the left, we're going up forever. So, comma, positive infinity, and in infinities, we always put parentheses. Okay? Because infinity is not a number, it's just an idea. So there we go. That's how you restrict the domain. So what I suggest, your teacher might want to, some other teachers might do it slightly different. What I suggest is just graph the function completely as you learned before, and then start talking about the restriction and paying attention to all the details. Okay? And then you apply the restriction. So let's do one more. Let's go ahead for number 2. Number 2 here, for the function f of x, equals the absolute value of x minus 2 plus a 1. So we have out here a plus 1, which shifts the function up or down, right? And then you have this this 2, minus 2, which shifts the function left or right. So you have a horizontal shift here, and then we have a vertical shift outside. So, and we have a absolute value function. So let's do a quick recap. I like to put my information here on the side. Okay. We have a V shape. It either opens up or opens down, is our V shape linear absolute value. Because in front of my absolute value, there's an invisible 1, then I have a slope of 1. So my slope of 1, it has a slope, okay? It's a linear absolute value. The value that I would like to plug it inside of here to get a 0 would be a positive 2. If I plug in a 2, 2 minus a 2 gives me 0. So if I plug in a 2, that gives me my starting point. The opposite of what is in here is a 2. And 2 minus a 2 is 0. And the absolute value of 0 is 0 plus a 1. Then we result the y value in a 1. So when I plugged in a 2, I got a 1 as a y value. So my starting point is 2, 1. Okay? Some of you by now should get a hang that opposite of what is inside of here results in the same of what is out here. So opposite same for h and k. Some of the students will start getting the hang of that. So this is our h and k, which is our starting point. Okay? So I'm going to go ahead and graph the entire function, but I'm going to do it in pencil, and I'm going to do it lightly. I'm going to do it with a pencil, okay? So we're going to go to the starting point of 2, 1. Let's go on the x value right here. 2, y value 1 is right here. That's our starting point. I'm going to use the slope of open up, up 1 over 1 to the right and 1 to the left. And because it's a linear, I can count it, I can keep going one more time. Up 1, run 1 to the right, and then up 1, run 1 to the left. You can do a couple more times, continue the pattern. Let's do it slightly, let's not do it dark, okay? It's a V shape that opens up like this, okay? Let's do just a light sketch. Now let's talk about right here. Our very first bullet point is the restriction. Okay, so there's my restriction. You're going to graph f of x if you are the x values. I only want, instead of only, instead of if, I'm going to use the word only. Graph f of x only for the x values between 1 and 4. So I only want 1 and 4. So let me, in green, I'm going to find 1, which is right here. 1, 2, 3, 4. So there we go. I label 1 and 4. And I'm actually going to highlight everything in between. There we go. I just want between 1 and 4. This is my domain right here. Okay? However, notice that under the number 1, we are not including the 1. So let me make a note to myself. Not include 1. But because I have an equal, okay, it's the x's that are less or equal to 4. Because we have that equal, the 4 is included. Okay, so I'm not including the 1, but I'm including the 4. When I don't want to include something, we're going to use an open circle. When I want to include something, I'm going to use a closed circle. Okay, open dot or closed dot, however you want to call it. So when I'm not including something, I'm going to use an open circle. When I do want to include something, I'm going to use a closed circle. Okay? But we have to know what happens at this domain. When I plug in a 1, what happened? What value do I get? When I plug in a 4, what value do I get? So let's evaluate, which is the next bullet point, is the evaluate. Okay? That's why evaluate is so important. Okay? Evaluate something. So let's plug in a 1 in our absolute value function. I'm going to do the math right here on the side. F of 1. Okay, I'm replacing the x value in my function with the 1. So absolute value of 1 minus 2 plus a 1 outside. inside of the absolute value, 1 minus 2 is the absolute value of negative 1, okay? 1 minus 2 is negative 1, and I still have this plus 1 outside. The absolute value of negative 1 is just a 1. Now I can drop the absolute value. I use the function absolute value. So the absolute value of negative 1 is 1 plus 1, which gives me 2. So when I plugged in a 1, I got a 2 as my order pair, okay? 1 comma 2, which it makes sense. Look at our dot was at 1 comma 2, okay? So everything that is less than that, I have to erase it. So let me go ahead and erase it. Erase my graph. Okay? And because we remember that the 1 is not included, we're going to use a open. Okay? It's open circle. So at this edge right here, I'm going to put a open circle. All right? Let me erase that little dark dot inside of it. There we go. Open circle. Let's go ahead and evaluate when I plug in a 4. So f of 4, inside of the absolute value, instead of x, I'm writing a 4 minus a 2 plus a 1 outside. 4 minus a 2, that is a 2 plus a 1 outside. The absolute value of 2 is a 2 plus a 1, which results in a 3. So when I plugged in a 4, we got a 3 as a y value. So the order pair is 4 comma 3. Remember, 4 is included, so we're gonna use included. We're gonna use a closed dot, okay? So on 4 comma 3, 4 up 1, 2, 3. Let me erase it right there. Anything after that, we cannot graph it. And let's put a closed dot. So I have closed on the right but open on the left, and literally I only graphed part of my graph. It looks like a piece of my absolute value function. Okay, that's why on the top it says what? We're graphing only a part of the entire function. That's what this type of graph we're doing today. So there you go. It's a really, really small part of our graph. Now let's talk about domain and range. Okay, the domain and range in interval notation. Remember, we can only use brackets or parentheses. There's a reason why I like to highlight my domain, so I see what happens here. I only want between 1 and 4, so my domain, D for domain, I'm not including the 1, so I'm going to use parentheses, but I am stopping at a 4, and I am including the 4, so using brackets, okay? You have to make this connection of not including the 1 is open, so when I talk about the domain, I'm going to use parentheses, and when I'm including something, if it's closed, then I'm using bracket, okay? Now let's do the range, okay? The range is the y values. Well, when I plugged in a 1, we got a 2 right here. Come back to my order pair. When I plugged in a 1, I got a 2. That is the y value for 1, and when I plugged in a 4, I got a 3. But those are not the lowest point of my graph. Those are the edge of my graph, right? The lowest point of my graph is right here where I started, okay? Remember, we're looking at the y values. So my lowest point of the graph is actually a 1 right here. So 1 for the y value, okay? And I'm including that. And then I went as high as to 3. That's the highest value of y I see here. We went all the way up to a 3. I know you're probably a little bit confused right now because you're thinking of 1 comma 2, but 2 is not the lowest value of the graph. The lowest value is right here where we started, okay? Remember, a range, we're looking right here at the y values. Okay, we went from 1 to a 3. Okay? It's a lot of details, including, not including, open circles, parentheses, included is closed circles, so you have to use brackets. A lot of details. Okay? Let's do another one. Let's do a exponential. So, let's take a look at the original function before we restrict it. So here's the original function. Okay, let me go ahead and separate all the space. I write big. Okay, here we go. So we have our original function, f of x equals 2 to the x power minus 3. If you remember, exponential function is a little tricky. I'm going to do a little tiny sketch here on the side. An exponential function, I need a little bit more space here. Exponential function always has this open circle, okay? That's where our h and k starts. And then you have this dashed asymptote, okay? It's a line that, invisible line that we don't touch. And then we graph the point right above it. And then we move to the right 1 unit, and then we go up the base. Okay, we go up the base, and that is an exponential function. Okay, that's a rough sketch of exponential function. We go 1 to the right, and then up this base value right here. Okay, and the h and k is the open space right here where we put the asymptote. So that is the rough sketch of a graph of exponential. So with that in mind, let's see what we have here. We need to find out our starting point. We know it's an exponential. We know the base of 2 here, okay? So let's start our starting point. If I plug in a 0 for x up here, okay, so I'm going to start with my starting point. If I plug in a 0 for x, let's see, 2 to the 0, anything to the 0 equals 1. So 2 to the 0 is a 1, and a 1 minus a 3 results in a minus a 2. Okay? So this is our starting point of the graph if I am to actually graph the function 0, negative 2. So 0, negative 2 is right here. That's my actual graph. However, right below is our h and k. So that's where I put my open circle and I draw my asymptote. Okay? Let's double check. If I do 0, negative 3 where I put my asymptote, my open circle, 0, negative 3 is our h and k. H and k is 0, negative 3. Okay? 0 for x gives me negative 3. That's our h and k. We don't touch it. But my actual first point is 0, negative 2. Right there. Okay? If I go to the right of the h and k and count the base of 2, so the base of 2. So go to the right of h and k and go up 1, 2. There we go. And then my graph goes to the left. Oh, I shouldn't do it in pencil. I shouldn't do it in pen. I need to do it in pencil. So if I go to the right forever and to the left forever, there we go. So I have the graph of the exponential. However, we have a restriction. Now let's see the restriction right here. Okay, this is the restriction. Graph f of x only if the x's are less than or equal to a 3. Because it's equal, we're going to include the 3. But let's see what happens at 3. Okay, right here is 1, 2, 3. Here's the 3. I want all the x's that are less than 3. So I'm going to go ahead and I'm going to highlight my domain. Okay, just because I want to remember that I'm going in this direction. And I'm stopping at 3. 3 comma what? I need an order pair, right? So let's go ahead and let's evaluate. Evaluate. Okay. So f of 3, I'm replacing the x value with the 3. So 2 to the third power, that's where I replace the x with the 3, minus a 3. Okay, we do exponents first. 2 to the third power is 2 times 2 times 2, 3 times, right? Let me go ahead and put a note to myself. It's 2 times 2 times 2, which is a 8. Okay? So 2 to the third power is 8 minus a 3. equals 5. So when I plugged in a 3 for x, we got a 5 for y. So I'm going to go 3, 5 on my graph. And I'm going to erase my graph. I need to stop at 5. Okay? So in pencil, 3, 1, 2, 3, 4, 5. Because we are including it, we have an equal. I'm going to make a closed circle. And my graph is supposed to go all the way to that closed circle. Now that I know that my graph stops there at 3, 5, and it can go forever to the left, now I can go ahead and do a, with the red pen and with the closed dot. There we go. That's my graph. So when I plug in a 3, I got a 5. That's evaluating right here. And let's go ahead and do the domain. The domain is all the x values, okay? So remember, we highlighted the x values all the way from negative infinity, and we're stopping at a 3. Then I double check over here. Am I including the 3? Yes, because I have an equal under, so I'm going to put a 3 with a bracket. Now let's talk about the range. The range is kind of tricky because our starting point of the graph was 0, -2, but our h and k is 0, -3. So I am coming really close to this value of -3, but I'm not touching it. Okay, notice that my graph keeps going below the -2. It's getting really, really close to this -3 value here, but it's not touching it. So I'm going to say -3, but not include it. And it goes up to, stops at a 5. It does not go up forever. It stops right here at the 5. So we stop at the 5. Because it's a closed circle, we're saying we're including the 3 and we're getting a 5. So I'm going to put a bracket. Okay? So in exponential, you have a lot of details, including this asymptote right here that we're supposed to count in our range when we're talking about values of the range and the values of the domain. I like to highlight it as well. So it's a lot of details, okay? So if I'm going to flip the page, it's blank. It's a lot of details. So remember really quick, when you want to include something, we use a closed dot. So when I'm talking about domain and range, we use brackets when we're talking about interval notation. When I'm not include, when I don't want to include something, we have to use an open circle, and then we use parentheses. Okay, so you're going to have to remember that. So when we have something that has a equal under, if you have an equal, this means is include. Okay, and when you don't have an equal under, okay, if you notice that there's not an equal under, that is not include something. Okay, so maybe we need to practice a little bit that in class, or send me a message. I'll make another video for us to practice including and not including values of x's and y's. Okay, so hopefully that helps you with doing some of your homework. All right, good luck. Take care.